Is that real?
I mean, whether it's real or not, the fact that you showed me an edited image of a rocket,
I'm asking you if it's real or not.
I mean, I can show you a clip from Avengers and ask you if it's real or not.
The Avengers clip is better than this. They're irresponsible.
That's not true.
Well, that is true. Look into it. So here's a rocket. You have to tell me honestly if you think this is real or not. This thing
is that a real image? Yes.
Is this a real rocket? Let's see. Now watch. This. We're going to have different shots. I mean, we have an onboard and we have a rocket. We have a camera on the ground.
What are you showing us here?
I'm showing you a rocket going to space.
Okay, I'll tell you what. I don't see any boosters. I don't see any, unless it's a solid rocket booster with no people on it.
Look at the smoke coming out of here. How fast is that moving? Look at the difference in height. The onboard, now this is falling. This is over 10 or 20 feet. So no, it's on its way down. It just went up. It's going to land. It's going to land.
There's no context for this video. Is this a SpaceX test?
I'm going to get to that. I just want your honest. I don't want to give you context because I want your opinion. And then I'll give you the context. Look at the speed of the smoke coming off of here. Is this thing free falling? But now look how high it is. All of a sudden, this is not out of order.
These are two different images.
Okay.
I mean, this is clearly
not real. Now this is falling. Now look how high it is. And now watch. The 3 engines are going to turn on. The cameraman's going to, with an edit, get right underneath it, and it's going to burn out. 2 engines are going to burn out. Look, 3 engines are lit. 2 of them are going to burn out. 1, 2. And now with one lopsided engine, it's going to land upright with a whole bunch of smoke and land right where it was supposed to land. This is a real Elon launch. This is the
there you go.
That's going to Mars. So now you believe it's real, even though what you just saw is ridiculous.
But that was clearly edited. That was clearly edited to make it look.
What was edited to make it look what?
Let's break down something that doesn't quite add up if we're living on a globe. Imagine traveling south of the equator. If Earth is a sphere, the lines of latitude should get smaller and smaller as you go further south, right? But what if the opposite is true? Here's the problem. On a globe, the closer you get to the South Pole, the tighter those latitude circles should become, shrinking until they meet at the pole. But real-world measurements show something totally different. For example, take the distance between Sydney, Australia, and Nelson, New Zealand, around 1,550 miles. Simple math tells us that if Earth was a globe, the total circumference at that latitude should be around 25,182 miles. But this number is actually larger than the equator's supposed 24,901 mile circumference. So, what's going on here? This means that, as you move further south, instead of shrinking, these lines of latitude seem to be getting bigger. From Chile to Australia, the distance is over 10,500 miles across. But based on the globe's model, this number should be much smaller. Calculations done between South Africa and Australia, or even between Sydney and Wellington, New Zealand, show similar results. The Earth's southern latitudes appear much wider than what the globe model predicts. How could this be explained? Well, this fits perfectly with a flat Earth model. If the Earth is a flat plane, it makes sense that the further you travel south, the wider the distances become. It's like stretching a map outwards. The closer you get to the edges, the larger things get. But for the globe model, these distances don't match up, leaving us with a major discrepancy. And here's the kicker. Many navigators have reported that they were off course when sailing in the southern hemisphere. Why? Because they were using calculations based on the globe model, which seems to fall apart the further south you go. Captains were finding themselves far from their intended destinations, a huge hint that something isn't right. If you're as fascinated by this as we are, don't stop here. Check out more videos on this topic. We've got plenty of mind-blowing discoveries that challenge everything we've been taught.
On flat Earth, down is down, right? On globe Earth, down is every direction towards the center while you're spinning, while you're orbiting, while you're flying through an infinite space vacuum. So that's a little weird. But there's a thing called electrostatics. This is not a theory. Electrostatics is everything from the air you breathe, the food you eat, your body, yourself, rocks, everything. Everything has an electrostatic charge. The Earth has a negative charge to it, measurable, testable, repeatable, provable, negative charge to it, and the sky is a positive charge. So we can test that. So we can take things, like I got these helium balloons here left over from a party, and there's just a button right here, and it's floating like 2 inches above the ground, and this line, that wire goes to a Van de Graaff generator, and we're going to introduce a higher positive charge to it. So when we add a positive charge to it, all of a sudden, it's more attracted to the Earth. Am I changing the gravity, or am I changing the electrical charge to it? Right? And then when we discharge it, it goes back up. Now, we can do the same thing with a negative charge. You put a negative charge into something, and it repels itself from the Earth? Are we changing gravity, or are we just changing the electrical charge? This is a drone from MIT. It looks like a bunch of milk crates, and it has no moving parts, and it flies just by changing its electrostatic charge. You know, the XRT-3B, that triangular secret aircraft. You can look up. It's disclosed information that it lifts and propels using electrostatics. One last thing about electrostatics. They tell us electrostatics, which is testable, measurable, repeatable, modelable, and we can experiment with it, is 10 to the 39th power stronger than gravity. 10, that's 1 with 39 zeros. Your mind isn't capable of fathoming the difference in that. A trillion is unfathomable, and that's only 15 zeros or 12 zeros, okay? And this is 10 to the 36th power. So if gravity was real, and electrostatics already are real, gravity is a theory, electrostatics is not a theory, 10 to the 39th power, what makes things go down? Electrostatics is the answer.
And may I just say this real quick?
So we've all heard of the Red Bull space jump, where this dude jumps from over 120,000 feet above sea level. And from that height, you should see some curvature, right? Curvature, not convexing. Why is the globe convexing? Does that make any sense to you whatsoever? If we live on a globe, how can it simultaneously be doing the absolute opposite? Of course, I know for a fact we live on a globe, but I also do know that this is a fisheye lens, a wide-angle fisheye lens. So if you hold it upside down, it's going to do that. But if you hold it straight up, it's going to do that. Am I saying that they're faking curvature with a wide-angle fisheye lens? Of course not. And this entire video is just for laughs. But it is pretty interesting how this globe looks on this video, isn't it? I mean, he actually did the jump. He actually went that high and did the jump. But why is he having to mess with the visuals of this video being presented to us? You have to ask yourself those questions. So yeah, I mean, it does it multiple times throughout this video to where the Earth looks both convex and curved. Oh, so now we live on a donut Earth. It's literally a giant donut? What is going on? I don't understand how this could be possible if we live on a globe. Something's going on, something's fishy, they're hiding something from us. But this was just a Red Bull space jump, and it was for laughs and giggles, and he just did it for entertainment purposes. Just like this video. I have no idea what I'm talking about, and I have zero eligibility to anything that I say. However, I do know that that is a fisheye lens. Just kidding.